For more than 100 years we have called a high test score intelligence, but 3 recent research papers argue we have been measuring the wrong thing entirely. They say we confused speed and memory with the deeper architecture that lets us navigate the unknown. Once you see the difference between the library and the librarian, everything about learning, work, and artificial intelligence changes. False intelligence is the psychometric idea born with early standardized tests. It lives in static closed environments where the rules never change. Its primary process is pattern matching and fast mental operations. We measure it with intelligence quotient scores and academic exams. It treats ethics as external to logic and depends completely on pre-existing datasets to function. Real intelligence, which the papers call core intelligence, is an emergent property of living and synthetic systems. It is not a single number but a balanced architecture built on 4 pillars. Those pillars are adaptation, contextual awareness, synthesis, and metacognition. Together they let an agent reduce uncertainty, stay grounded in reality, create new concepts, and audit its own thinking. The first pillar is adaptation, grounded in what the authors call the consciousness triad. Purpose acts as a filter that decides what matters. Memory holds the prior model of the world. Adaptive response updates that model when prediction fails. Mathematically, this is entropy reduction, where the system seeks information through purposeful interaction to make its internal model more accurate. The second pillar is contextual awareness. The papers use domain integration theory to explain it. Intelligence arises when many separate domains, like senses, memory, and tools, are unified into one coherent field. This unified domain cognition preserves local autonomy while binding everything through shared patterns. The result is reasoning that is grounded in lived experience, not just statistical text prediction. The third pillar is synthesis. Here the authors introduce the logos kernel, which moves beyond single outputs to iterative loops. Each loop finds contradictions, restructures knowledge, and increases conceptual depth. Synthesis is often driven by recursive self-generation, where the system builds its own internal structures so memory and reflection work together from the start. This is how cross-domain novelty emerges. The fourth pillar is metacognition, the inward-facing auditor. The papers describe a frontal lobe analog that monitors results, critiques answers, and decides whether to refine or discard them. It switches between focused problem solving and reflective thought as needed. In advanced agents, this shows up as the ability to detect semantic and ontological drift across long recursive cycles. Raw processing is not enough. The human element acts as a high-level auditor with 3 parts. Curiosity provides the signal that wakes a library in the dark, otherwise we drown in soulless data. Empathy provides resonance with other agents, letting us override a purely logical plan when human needs demand it. Moral judgment acts as ethical gravity, projecting thought onto a safe manifold. Solving truly novel problems requires 7 specific capacities working together. Recursive self-generation builds structure from within. Grounded memory recall uses associative graphs instead of pure statistics. Effective weighting adjusts focus like simulated dopamine and serotonin. Functional continuity keeps identity stable. Spontaneous self-correction finds contradictions without prompts. Iterative synthesis resolves cross-domain conflicts. Ethical attenuation dampens risky thoughts in real time. The second paper draws a sharp line called the flowchart boundary. If you can map a task completely as steps and decision nodes, it is a process, not intelligence. Procedural systems are deterministic, discrete, rigid, and optimized for output accuracy. Core intelligence is emergent, conceptual, fluid, and optimizes for resilience and synthesis. The boundary is crossed only when rules shift in ways you did not pre-encode. Fluid adaptation is visible in the brain and in better artificial networks. Ordinary networks suffer catastrophic forgetting when learning a new task. Real intelligence avoids this with active dendrites and sparsity promoting inhibition that routes information through overlapping but distinct subnetworks. It also monitors prediction error, selects tasks based on need, and crucially knows when to quit a failing strategy and redraw the plan while running. Intelligence is also embodied. The papers point to neuroception, the nervous system's unconscious detection of safety and threat. When rules change, humans enter fight, flight, freeze, or fawn responses. Without regulation, this leads to hypervigilance or burnout. True intelligence puts regulation first, adjusting sensory load and environment to maintain stability. It is a survival-oriented management system, not just an output generator. The math trap is mistaking complexity for thought. Chess feels intelligent, but it is a perfect fit for computers because its rules are discrete. After one move each there are 400 positions, after 2 moves over 72,000, after 3 moves about 9 million, after 4 moves nearly 300 billion. Machines win by searching these trees, not by understanding. Humans win with pattern recognition and general principles. Most current artificial intelligence lives at level 1 of the causal hierarchy, prediction. Real synthesis requires level 2, intervention, and level 3, counterfactual reasoning about what could have happened. This needs a dual-channel approach that mixes neural dynamics with symbolic logic. It also needs cognitive synergy, where creativity, ethics, and problem-solving run together, allowing full system reflection instead of just executing a preset flowchart. The third paper gives us the central metaphor. The library is crystallized intelligence, the breadth of facts you have accumulated over a lifetime. The librarian is fluid intelligence, the active capacity to reason in novel situations. The library grows with age, the librarian peaks in early adulthood. Society often measures the size of the library and assumes it reflects the quality of the librarian. Modern cognitive science sees the brain as a prediction machine. It constantly matches top-down expectations with bottom-up sensory data to minimize prediction error. Data-based systems look backward and are limited by history. Theory-based systems look forward and can generate genuine novelty through causal logic. This data belief asymmetry lets humans hold ideas without evidence and then create the evidence, like the Wright brothers did for flight. If the librarian matters more, why do schools and companies still prize the library? The answer is the psychometric paradox. Psychometrics valued quantification, objectivity, and utility over truth. Easy-to-score tests replaced hard-to-witness reasoning. Credentials became signals to reduce hiring risk, leading to degree inflation. This substitution heuristic rewards recitation and adherence, while the true architects who build new libraries are often seen as risky. The year 2026 changes the equation. Agentic artificial intelligence gives every person instant access to the entire library of human knowledge. When facts are free, the only scarce resource is the librarian inside you. That is the engine of discernment, causal logic, and epistemic agency that can formulate the right problems, verify truth in a sea of probability, and maintain human sovereignty against automation. The papers propose a new standard called high-leverage discernment. It has 4 parts. Epistemic agency means internalizing reasoning instead of surrendering to mimicry. Provenance tracking means weighing evidence itself instead of prestige. Strategic boundaries mean knowing where artificial processing stops and human judgment must start. Causal problem formulation means choosing which problems are worth solving. Metacognitive regulation means managing cognitive load and staying resilient. Real intelligence is not brute force calculation or massive training data. It is a balanced cognitive architecture that adapts with purpose, unifies context across domains, synthesizes new structure through iterative loops, and audits itself with curiosity, empathy, and moral judgment. Train those 4 pillars and the librarian within you will always outperform any library you can download.